Hey guys, welcome to another episode of my channel. So today we are also going to deal with RFID and the RC522 module for ESP32 and ESP8266 microcontrollers. And this in front of you, it's our code from previous episodes. So if you have not been following this mini series of tutorials, it's strongly recommended for you to watch at least few episodes in order to jump into it, because it makes no sense for every subject to explain everything from the beginning. And subject for today is value blocks. You could understand value blocks as values intended to be changed for whatever purpose that might be. And in order to use it, you actually have to remember only few functions like set value, transfer, increment, decrement and get value. But first thing that we are going to deal with is actually format. In order to use value block, your data block needs to be formatted correctly. And first thing that I'm going to do now, I'm just going to delete this piece of code immediately after authentication. So we need to authenticate in order to deal with value blocks, and I'm going to make some space in here. But first we are going to create one function. It's going to be void. I'm going to name it FVB, and that stands for format as value block, and I'm going to comment this code. Okay, we need to provide byte address. This is address of our block. Make some space because we are going to need it. Now what we need first, we need byte buffer 18 elements, because first we are going to read the data from our block, and byte len. Okay, it's going to be size of buffer, and we are going to create status code RFID RC522 status code, call it status. So now we are going to read data from our block, and we don't need to authenticate because we are going to call this function immediately after authentication. Okay, so first I'm going to check status. Is going to be RC522 myfer read. Okay, we are going to read from address, we are going to read into buffer, and we are going to provide address of len. And of course we are going to check status. If status not MFRC522 status okay, what we are going to do, we are going to print reading failed, and get status code name for status. Okay, and we are going to return. So if we cannot read that block, there is nothing else to be done. Now we are going to check conditions in order to see whether our block is properly formatted already or not. Okay, and we are going to have a lot of conditions. So now to answer question, what are conditions in order for some block to be properly formatted as value block? First 4 bytes of value block are going to hold a value that we are going to store into that block. Second 4 bytes need to hold complementary values. Third 4 bytes need to hold copy of original value. And last 4 bytes need to hold address. First of that last 4 bytes is going to hold address of block. Second, it's going to hold complementary value of address. Third, it's going to hold copy of address. And fourth, it's also going to hold complementary value of address. So how we are going to perform that check? So first condition for buffer 0 must be buffer 4th byte, but you're going to put this tilde sign, so complementary value of 4th byte. So if, for example, byte on buffer 0 it's 0x00, byte on buffer with index of 4 must be 0xFF in order for value block to be properly formatted. Okay, if you understand that part, let's go on. So now we have to say buffer with index of 1 must be equal to complementary value of buffer with index of 5. Okay, I'm going to copy this 2 more times. So now we have 1 5, we are going to have 2 6 now, and we are going to have 3 7. In next row, actually I'm going to copy this entire row, it's easier. So now byte 0 must be equal to byte 8. Byte 1 must be equal to byte 9. Byte 3 must be equal to byte 10. Byte 4 must be no, I made some mistake. In here it's actually 2. 2 must be equal to buffer 10. So we have 0 8 1 9 2 10, and we are going to have 3 11. And in third line we are going to deal with address buffers, meaning address bits. So here we have 12. 12 must be equal to a complement of buffer 13. Next, 12 also must be equal to buffer 14, and 12 must be equal to complement of buffer 15. Okay, I think that we covered all of conditions. Okay, we are going to know soon enough. So what we are going to do if our block met these conditions? So what we are going to do, we are just going to print something to our screen, some message like serial println format it's correct. All right, remove unnecessary empty space, then else. If format is not correct, we are going to format. So we are going to create another buffer, byte value block, and we are going to hard code those values. So we need first for bytes 0, so 0x00, 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 and one more 0x00. Next four values are going to be reversed, so we are going to have 0xFF, 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 and once more 0xFF. Now we have to make copy of these first four values, so 0x00, 0x00, two more times, 0x00, one more, 0x00. And now we have to provide address byte, and now we are going to have complementary value of address, one more time address, and one more time complementary value of address. Now what I did, complementary value of address. Okay, I think that is fine. All right, and finally we are going to write this. I'm going to copy this piece of code in here. So we are going to check status, but we are going to write value now. Into address, we are going to write value block, and we are going to write 16 bytes. If something goes wrong, we are going to print formatting failed, and we are going to print status code to our serial monitor. Okay, this part is done. I'm just going to remove an unnecessary empty space from here. Then I'm just going to put declaration of this function to the top, and we are going to call this function immediately after authentication. So FVB, and we are going to provide a number 4, so we are going to format our block number 4. And with dump to serial, we are going to see the result. Okay, I'm going to build this code, upload it. Okay, going to open my serial monitor, and now we are going to test my card. All right, let's see what we have in block number 4. All right, we have it. So we have 4 times 0, 0, 4 times FF, 4 times 0, 0, and we have 04 as block address and complementary value. It's FB. Let's see if we have some warning message. No. So this is all right. Now what we are going to do, you can put this function call in here without any problem. So we are just going to test whether our block is properly formatted or not. And because we just finished with formatting, this piece of code it's not going to do anything. So I'm going to comment this dump to serial call. I'm going to make some space, and now I'm going to show you how to use your value block. So first, what we are going to do, we are going to set some value. I'm going to check for status, so MF RC55, set my first set value. We are going to set value to value block, and we are going to provide some integer value, let's say like 18 or something. We are going to check status. For that, I'm going to copy this piece of code. Okay, and we are going to change this into something like set value error. All right, now I'm going to increment this value. I'm going to copy this part, and instead of set value, we are going to use increment, and we are going to increment this value of 18 by, let's say, 7. So now we should have 25. But after function set call, we don't need to call function transfer. Now we are going to need to call function transfer. So function transfer you're going to call after function increment or decrement. Okay, so in order to call that function, first I'm going to change this error text in here, like increment value error. And in here I'm going to set transfer, and this function needs only one argument, and that is block address. Okay, now I'm going to print that value to the screen with function mfrc55. Not read, it's actually get value, my for get value, and we are going to get value from block number 4, and we need one integer value. I'm going to provide address of that integer. So after this function is executed, value from our block is going to be stored in this integer. And what I want to do, I want to print that value to the screen. Better with printf, it's easier. Value from our block, it's %d and new line. So now I'm going to use this value in order to print to the screen. And now I'm going to copy this part. Now we are going to test decrement. So what we have 18 and 7, that's 25, and now we are going to remove 15. Okay, so now we should have 10, and immediately after decrement we are going to call myfer transfer, and now I'm just going to print this value to the screen. All right, everything looks right. Okay, I'm going to build this code. So basically, what should we get out of this code? Let me show you. First, we are setting value to 18, then we are rising to 25, and then we are printing 25 to the screen. Then we are decreasing value by 15, and now we should print 10 to the screen. So that's all, and I'm going to upload this piece of code. Okay, that's cool. Opening serial monitor, restarting my microcontroller, and let's see what we are going to get when I press my card to my RC522 module. Wonderful. Value from our block it's 25, and then value from our block it's 10. So guys, that's all for this episode. I hope that you learned something new and something interesting. So please like, subscribe, and see ya.